everyone. We now want to talk about the hyperbola. Now, it's very similar to the ellipse in many ways. It's the set of points where the difference in the distance to two fixed points is constant rather than the sum. So if my two fixed points here, the foci once again, and I pick a point at random on a hyperbola, then that distance minus that distance is constant. But because of that definition, I can have two different pieces here and also have this difference be constant. So there's two different pieces going in different directions here. Now, as a result of this, if we put this on the xy plane and then give this some orientation here. So let's call this focus c comma 0 and negative c comma 0 like before. We'll call this vertex a comma 0, negative a comma 0 like before. Now, it's very similar to the ellipse in that the way I set up the relationship between the a and the c is if I take the difference in this point to here, okay, that difference right there is c minus negative a. Now the difference from this point to this point is c minus a. And when I perform this, I get, it's exactly 2a, which is interesting because that's the same value we got in the ellipse, except this time c is larger than a. Now, as a result, we get an equation of the form x squared over a squared minus y squared over c squared minus a squared, because c is bigger than a. Now, this is a very inconvenient form. So if I said, let's just go ahead and replace that quantity and call it a new value, b squared, then this whole thing will equal 1, and this is the general form of our hyperbola. Now, the hyperbola in this form is going to open up horizontally because I can replace x with plus or minus a and y with 0, but I cannot replace y with a value and x with 0. But if I reverse the order of subtraction, all that does is gives me a hyperbola that opens up vertically. We'll look at that one later on. Now, in this situation here, I want to solve for y, which is interesting because clearly I will not get a unique value. But if I get the y term by itself, and I have something of this form here, now I want to manipulate this. So I'm going to start by factoring out x squared over a squared, and that will leave me with 1 minus a squared over x squared. And do a quick check of that. Now let's multiply both sides by b squared. And now if I take the square root of both sides, I'm going to get something of the form y equals plus or minus b over a times x times the square root of 1 minus a squared over x squared. But now we recognize this term right here. This is called a transient term. The larger x gets, the closer this quantity becomes to 1, meaning I have an asymptotic relationship here. As x gets larger and larger, this role becomes less and less and less, and we can say that y, therefore, is asymptotic to plus or minus b over a times x, which is interesting because those are two lines. In fact, those are two lines that basically will look like this. And most of you remember when you learned how to graph a hyperbola, you drew two lines, but you may not have known where they came from. They come directly from this equation here. And these lines are called, again, asymptotes. Now, continuing, if I shift the center to h comma k like we've done in the past, and now I have a hyperbola that starts somewhere else, I have two possible forms of the hyperbola. If the x squared term comes first, it's going to open horizontally. If the y squared term comes first, it's going to open vertically. But in both cases, the slopes of my asymptotes are the same. It's plus or minus b over a. Think rise over run. The number under the y tells me my vertical change. The number under the x tells me my horizontal change. That doesn't change any. And then simply using the point slope formula, you notice I'm just taking these values, I have two lines right here. So let's say, hypothetically, these are the two lines. If I'm dealing with this equation, I'm going to simply move left and right a units. Let's say that's a units. And then all I have to do is approach the asymptotes. This would be an example of this hyperbola. But what's beautiful about this is if this is the equation, I have the same asymptotes, but now I'm going to have a different hyperbola, because now I'm going to move up and down b units. Let's say that's b units, and that's b units. And I'll get something that looks like this. So this is a reflection of this equation. This is a reflection of this equation, and both have exactly the same asymptotes. Now, given the following equation of a hyperbola, I'd like to find the center, foci, and asymptotes, which means I need to write it in the completed square form similar to the ellipse. Now, one of the reasons we know this one's a hyperbola actually is because I have a difference in the squared terms, where an ellipse would have a sum between the squared terms. So like before, we're going to complete the square. So we'll get the x terms together first, then the y terms, and then throw the constant on the other side. Now, at this point here, I have to factor out the 9, leaving me x squared plus 4x. I will factor out the negative 4. Now, this is where some people get in trouble. Be very careful at this point here. Plus 8y equals 352. Now, I haven't actually done anything yet except rewrite it. So now we need to figure out what goes in here to make this a perfect square. So this is now 9 times x plus 2 quantity squared. So I'm going to put a plus 4. This will be y plus 4 quantity squared. So I'm going to put a plus 16. Now don't lose that. Now the question is, what did I just do to the other side? Well, I just added 9 times 4, and I just added negative 4 times 16. Aha! So I'm going to do plus 36 minus 64. And so this turns out to be 324. Now at this point here, it's almost ready to read the final results. So we'll multiply through here by the reciprocal. So I'll have x plus 2 quantity squared. 9 over 324 is 36, or 6 squared. 4 over 324 is 1 over 81, or 9 squared. So now we have the perfect form of our hyperbola. So from here I can tell that the center is negative 2 comma negative 4. Now in order to find the foci, I need to figure out the focal length. So we saw in this situation, c squared is the hypotenuse, or c is the hypotenuse of the right triangle formed by the a and the b. So my c squared will be 6 squared plus 9 squared, which would be 117. So c is the root 117, or 3 root 13. So therefore my foci, and because this thing here opened up horizontally, I will add that value to the x-coordinate. So the foci will be negative 2 plus 3 root 13 comma negative 4, and negative 2 minus 3 root 13 negative 4. Now finally, we need the equations of the asymptotes. So all I have to do is read the slope from this. Now remember, the slope is vertical change, 9, over the horizontal change, 6. So my slope is plus or minus 9 over 6, or plus or minus 3 halves. And now using the point slope formula with exactly these statements here, I find that my asymptotes are y plus 4 equals plus or minus 3 over 2 x plus 2. And there you have hyperbolas.